Whiteboard here for Manny. We're going to start with the chain rule. Now, first thing is, let's look at some additional derivatives. So let's look at derivatives day 2. I want to add a couple more in. The first one I want to add in is, what do we get if we take d dx of natural log of x? The natural log of x, the derivative of the natural log of x is 1 over x. Okay? We also need to take the derivative, know what the derivative is, of e to the x. It's just e to the x. It doesn't change. Now, the problem is what do we do when we have functions that have other functions inside it? If you know what I'm saying. What do we do when we have something like, say, instead of just having the square root of 2x, which we could do very easily, what happens if this becomes the square root of 2x squared plus 3x minus 1? This is really a function that we could do the derivative of inside another function. So how do we deal with that?
You just break it apart.
You can't. The square root symbol won't let you break it apart. You can't make it 3 individual square roots. So we have to do what we call the chain rule. And this is probably as complicated as it would get in this class. So in other words, if we take the derivative, d dx, of a function, f, that has another function inside of it. Does everybody understand that that's what that means? F of g of x. This would be g of x, and this part right here would be f of x, okay? If that makes sense. You looked at those last year in pre-cal. When we do this, what we find is we get f prime of g of x times g prime of x. In other words, we take the derivative of the outside function, and then we multiply that by the derivative of the inside function.
Just the square root of x for the f prime g of x?
Mm-hmm. Now, I'll show you some examples, okay? Let me show you some examples of how this works. Let's say we have, for example, we have x squared plus 1 to the 100 power. This is chain rule worthy because you've got something, your f of x is all of this. This is your f of x, okay? But it's also g of x. I'm sorry, this is g of x. The whole thing, including this, is f of x, okay? Get it? So, yes, watch how it works. This is a function that would be derivable inside something else. It's captured. You can't just raise both of them to the 100 power and go. And you wouldn't want to have to expand this out. There is no way. So this is how it works. We are going to take and start first with taking the derivative of this. If we take the derivative of the whole thing, boom, we would take and use our derivative rule, which is take the exponent and multiply it to the front, right? 100. And then this goes down by a power, doesn't it? So this becomes 99. That is this part right here. That's this. Okay? Now, because there is still another function on the inside, we now have to do this part, which is take the derivative of what's inside. Get it? So what would the derivative of x squared plus 1 be?
2x.
So then we multiply it by 2x. Okay? So this part right here is this. And then we just simplify. So this becomes 100 times 2x, which is 200x, times x squared plus 1 to the 99th power. Let's look at another example.
So we take the derivative of the whole thing.
Yep.
Be like 100, that.
Bring the exponent to the front, rewrite it with the exponent down by 1, and then take the derivative of what's inside.
Yeah.
Okay.
And inside would just be the 2 bringing out from the multiple, and
Yeah.
it goes down to just 2x.
Yeah.
And you multiply that together.
Yeah.
And so it's
X times. Yeah. Okay. So let's try another one. This works for the same way for things like this. Let's look at this one. F of x is equal to e to the 2x. And I want to find f prime of x. So we want to take a derivative of the whole thing. What did we say the derivative of e to the x was? E to the anything, x. Just e to the x. So this would be, taking a derivative of the whole thing would just be e to the 2x, correct?
Yes.
Then we have to take the derivative of the function contained inside, which is times, what's the derivative of 2x?
Okay. 2.
So the final answer would be 2e to the 2x. Do you get it? Kinda?
kind of.
Yes.
Well, let's do a couple more examples, and then I'll let you try a few. All right. First thing I want you to do is tell me, can somebody tell me why this qualifies for the chain rule?
Because everything's to the -1 power.
Yeah, because you've got it all in the denominator together, don't you? You cannot raise those pieces up separately. Do not do that. So we have to rewrite this as
X.
all raised to the... So now we have a function inside of a function, don't we?
Yeah.
All right, so if we're doing y prime, let's talk about the outside function as a whole. What would I do for the outside function as a whole?
Multiply everything by -1.
Good. So we take the -1 and we put it to the front, right? And then the whole thing goes down by,
1. So we negative 2.
To the -2.
and then we have to do what's inside, don't we? So now we take the derivative of what's inside, and that's what?
3x squared plus 10x to the 4th.
And then we clean it up.
So just
It would be negative 3x squared minus 10x to the 4th all over what?
parentheses x cubed plus 2x to the 5th squared.
Yes. And that would be the answer. So the chain rule allows us to do some stuff that's a little more complicated, doesn't it? You can also do this for natural log, believe it or not.
So the first one, we got x cubed 2x times the -1. And then we derivative that, which is just all times -1, and then it's square root of 2. The second part is just the inside.
Mm-hmm.
Just the inside, so you multiply that by the inside.
Yep.
And that last bit is always multiplied by the
Whatever the,
-1,
yeah,
not the inside.
whatever was out in front, yeah. You
Okay.
can't multiply by what's inside because it's to the -2 power.
It's the negative power. And
So
then
let's start-
Since it's -2, you have to move it down.
Yep.
Okay.
So y equals 3 to the 2x plus 7. There's a weird one, isn't it? But it allows us, the chain rule allows us to do this.
So 2x plus 7 times 3.
All right. So the derivative would be what?
6. Because you're multiplying by 3, right? So 6, 21.
Be careful. Derivative would be this to the front, right?
Yeah.
So 2x plus 7.
Do you not multiply by
3 to the 2x plus
can't you multiply?
Exponent goes down by 1. Doesn't it?
But it's in the.
So 2x plus 7 is the exponent. If that goes down by 1, guys, what is it?
2x plus 6.
Okay, so that's the outside part. Now we have to multiply it by, that is a 2x, because that's a 2x.
See a 1x minus x could.
No.
You
You subtract 1.
Just 1.
2x plus 7 minus 1 is 2x plus 6. And now we have to take the derivative of the exponent, the thing that's up there. So what is the exponent of 2x? What is the derivative now
2.
of 2x plus 7? So it's 2, so times 2. So what's the final answer here?
2x plus
Y
7.
prime is 4x plus
Plus 14
times,
times 6 to the
Oh,
2x.
oh.
yeah,
Wait, what?
Oh.
Oh, because that's technically
Yeah.
Yeah, 3.
yeah, technically. All right, so let's look at a couple more. Taking the
Oh, that's the
derivative of
multiplier.
the function that's inside the function. Think about it this way. Here is my outside function. Here's the inside function. That's your g of x. What's the derivative of g of x?
Yeah, that's the 2.
What's the derivative of 2x plus 7? Just, that's where that came from. This part of it right here actually comes from,
Oh wait, sorry. I thought that was like with the,
this comes from the yellow,
Yeah, I thought
this
it was
comes from the green derivative.
because I wrote it with the other one. I
Yeah.
thought it was the exponent. I was like, where?
No, it is not the exponent.
Yeah, I was about to say.
Yeah, no, it's down below.
3 to the 2x plus 6 to the.
All right, so now let's look at one that may be a little bit trickier that we can actually use a trick for. Natural log of 2 to the 3x power. Believe it or not, we're going to use a trick to do this one and make it simpler.
Ignore the natural log.
No. Guys, what do we do when we have a log that's something to a power? What can we do with the power?
So natural 3x natural.
Move it to the front. So this becomes 3x times the natural log of 2. And the natural log of 2 is a constant, isn't it? This becomes much easier.
Yeah, log of 2 is just.
So 3 ln 2 is all a constant, isn't it? Times x. Would you agree? That becomes really easy to take the derivative of, guys. Doesn't it?
Wait. Yeah,
So
but why
it's
did we move
just
the x to the end?
It's not 1.
No.
Why did we move the x?
If you take d dx of ax, isn't it a? Now, ask your question, Ryan.
Okay. So, why do we move the x to the end?
Log rules. Because natural log of x, natural log of 2, you understand why 3x went to the front. Log rules, right?
Yeah,
Yeah.
I understand.
Okay, so that becomes 3x times this.
Natural.
Well, this is a constant and this is a constant, so I put all of the constant terms together
Oh, and then
in front of the
multiply by
x.
Okay. So
Okay.
Because now when you take the derivative of a constant times x, the derivative is just the constant term, isn't it?
Constant term.
So if I take the derivative of 3 natural log 2 of x, what is the answer?
3 natural log 2.
Yes, 3 natural log of 2. You just peel off the constant. I just used a trick to do it. Now, can you always do that?
Yeah. Probably not.
Yeah, you can. Yes, I suggest it too.
Okay.
Now, if you just have natural log of something else, then it's a little bit weirder. But we can still do it. So I want you to try one. Y is equal to, in this case, the square root of r to the 4th plus 1. I would like you to find dy dr. And why did I say dydr?
Because R is the.
Yeah. See if you can find dydr. Chain rule is weird, but you get used to it. After a while, it's just practicing enough that you get the pattern down. Did everybody get the first example correct? That is e to the x. Yeah, that TV is so small. Which question?
Above it.
Mm.
So when you have this, you do it to half.
That's the square root,
Mm-hmm.
right? So put it in parentheses.
And in parentheses.
So now the outside would be this goes to the front, right?
Right. So that we
And then this whole thing goes down by 1, right?
right.
Parentheses.
Negative.
Yep. Yep. And then take the derivative of the inside, whatever's inside
So
parentheses.
take the derivative of
Yeah.
this, and then
That's it. And then simplify.
that's
Look, that's what I did. So this was
Mm-hmm.
1/2 went to the front, this went down by 1/2, and then the inside here would be 4 times r to the 3rd, right? That would be your derivative of the inside. So that would goes next to it.
that's that.
Yep.
And then
So then you can multiply this by this, and you get what?
That's 2 r to the 3rd.
Huh? And that would be in the top.
Top. Because
then
that's a negative,
it
you want
goes
to
to
bring
the
them
bottom.
down.
And it
So
becomes r to the 4th plus 1 is 1.
Plus 1?
Yeah, plus 1. I think it was plus 1 in the problem.
Okay.
And then the 1/2 is now positive, so it becomes a square root. Right?
So it just becomes.
Yeah. See? Got it.
Okay.
Now try the next one.
Alright.
really not so bad once you get the hang of it. And this puts you miles ahead of your calculus friends. The fact that you can do it on your roll. Because you won't learn that until the end of Cal. But you'll use it for this class. So, and you'll use it a lot when you go to college and go in those engineering classes and take electricity and magnetism with calculus. All right, so we need to add in some additional things. We need to add in what? We need to add in sine and cosine. So what are the derivatives of sine and cosine? d dx of the sine of x is equal to negative cosine of x. And d dx of cosine of x is sine x. Yes. Okay? Mm-hmm. That's what it is. Now, can you see why chain rule might come into play here? Oh, dadgummit, I did those backwards. Just looked at it. It's positive and the signs are changed. This is positive, this is negative. Oh, that's my oops for the day. Excuse me. dx of cosine x. The chain rule comes into play because sometimes it's not the cosine or the sine of x, it's the cosine of x cubed or 5x squared or such, okay? So if we're taking, where the chain rule applies, is if we're taking y equals the sine of 3x squared. So what is dy dx? So first you take the derivative of the whole thing. So that just changes to what? Sine. Take the derivative of sine and you get what? Cosine, right?
Yeah.
So sine 3x squared just becomes, but this is our f of x, and then this is our g of x. So now we have to take the derivative of what's inside. Does that make sense? So now we're going to take the derivative of what's inside. So what's inside is our g of x. So 3x squared, what is the derivative of 3x squared?
6x.
So 6x. That is not notice I put the cosine part in brackets because that is not, 6x does not get multiplied into 3x squared. The way you write this would be 6x cosine 3x squared. Yes. Because it's a completely separate chunk. So see if you can try one. Let's say f of x is equal to the cosine of 4x squared plus 2x minus 1. See if you can find f prime of x. Oh, I don't think we did a natural log one where you couldn't bounce it to the front. We should do one of those.
Oh, okay, it's negative. But we're just sticking negative right there.
Mm-hmm.
You got this one, it's negative.
Well, I mean, you can leave a negative outside, but as long as it's in the form, I mean, technically, negative times 8x plus
Yeah.
2 is still the same.
So, so we can keep it as negative parentheses.
Yeah.
8x plus 2. Okay.
Guys, you are never going to have a purely derivative question in this class. It's always going to be used to do something else. Same thing with integrals. It's part of, it is a workhorse to get you where you need to go. Because remember, yeah, absolutely.
Okay.
All right, so I want to do one more and then we're going to switch to integrals. We're going the other direction, okay? What if y equals the natural log of x cubed plus 3x? This one, we cannot swing anything to the front, can we? So this one, we have to actually use the derivative.
Yeah.
But this is chain rule, isn't it?
Isn't that already in FG
Yeah, it is an FG form.
already? So
This
it
would be all, this would be f of x, and this chunk would be... So you've got to think about, how do I normally do the natural log? How do I take d dx of natural log of x? What does it become?
Natural log.
1 over what?
1 over natural log.
No, 1 over x.
So it'd be 1 over.
Yes. 1
natural
over,
log of the entire-
just be 1 over, notice the natural log's not in here, is there?
Oh,
So it's 1 over,
x cubed. So it's like raising it to the negative 1
Yep.
power,
times what?
just 3x squared plus.
Good.
So take all that and raise it to 3x squared plus 3.
No, it's not
Yeah,
raised,
multiply
it's
it.
times. So you end up with 3x squared plus 3 over what?
X cubed plus 3x.
This is one of those weird ones. I would put a star next to this for natural log stuff, right? Because it doesn't act the same way. You don't have any bringing it down a level. The exponent doesn't come down, does it? Doesn't get multiplied by. Natural log acts differently. And so does e to the x, right? So you got to look at them separately. All right, so let's go the other direction. And let's talk about how do we do integrals. Okay? I am less worried about you doing integrals with chain rule, because you're not really ever going to do anything where you have integrals of chain rule, okay? In this class. Now, you'll get to how to do integrals with chain rule in calculus, but that's not my problem, all right? You just need to know how to do basic integrals, and you need to know how to do integrals with sine and cosine, okay? So what is the integral of sine of x dx? This is where you have to think backwards. What do I take the derivative of to get sine? Cosine. So if we're going the other direction, right? We're going to go, if we're integrating sine, we're going back to cosine, aren't we? So we know we're going to get cosine of x, correct? But if we were to take the derivative of cosine, it's negative sign, isn't it? So what do I need to throw in the front of this? Negative. Does that make sense? Yes, no, I don't know. Okay, look.
I thought it was
This is truly,
opposite.
if you take the derivative of cosine, you get negative sign.
Right.
Okay, so,
You take
The opposite
the
way.
integral.
So it's the opposite way.
yeah. Because you've got to end up with the negative, don't you? So how would I lose a negative to get a positive? I'd multiply it by another negative. That's why we put that negative in front. For sine and cosine. Okay? What is the integral of cosine of x dx? Mm-hmm.
Yes.
Do I need to put a negative in front? No, because when I take the derivative of sine, it gives me cosine, doesn't it? So these are straightforward. All right. So let's do a couple of examples and see if we can make sure we get this. Okay? Oh, we ought to also do this. What is the integral of 1 over x dx?
X.
Natural log of x.
Yeah,
Probably because you can go backwards.
natural log of x. And what is the integral of e to the x dx?
Yes.
E to the x. Okay, so those are the 4 new ones we've introduced today. So let's see if we can't figure out how to do a few things here. Let's do example 1. Let's do the integral, and of course if they're finite, if they are infinite, in other words unbounded, these are unbounded, aren't they? Notice I don't have a number, an a and a b here and here, do I? If they are unbounded, all we have to do is find the expression. If they are bounded, we have to plug in and do the subtract the difference.
Right.
Okay?
Upper minus lower.
Yeah, upper minus lower. You'll grow to appreciate unbounded because you don't have to plug anything in. Those are always really nice. All right, so let's try one. Let's try this. Let's find the integral of x cubed minus e to the x dx. So how do I do this one? I treat each piece separately, don't I?
So x cubed and then negative.
Yeah. We could do it this way. We literally could say take the integral of x cubed dx and subtract the integral of e to the x dx from it. As long as there's minuses and pluses, you can just separate it. So what is the integral of x cubed?
X to the fourth over
X to the 4th over 4. So this becomes x to the 4th over 4 minus, what's the integral of e to the x? Ta-da.
And then when it says if we have to plug it in.
Then we can just, at this point, you can plug it in from a to b if you need to. Okay? Try one on your own. Let me give you one. Let's see. Let's try, let's see, the integral of... Actually, let's do one more together. 5 natural log of x dx. Because sometimes that 5 in front freaks people out. You're like, what? Wait a minute. Guess what you can do here? That is a constant, isn't it? You can move it to the front.
So just 5 times.
You just pull it out. And then it becomes easy, doesn't it? So what is the answer here? Yeah.
Yeah.
Right, the integral of natural log is 1 over x.
The integral of natural log of x is 1/2
No,
I mean, one
No,
over
it's not.
X.
No, the integral of 1 over x.
this is natural log. The integral of natural log is,
One over X.
no, it isn't.
Oh,
Hang on, let me think about this.
weird.
Sorry, I should have done it the other way. Excuse me, because it's not. It's something really complicated that you won't ever have to do. In this class, at least. I beg your pardon. Let's do it this way. 1 over x. Let's do 5 over x dx.
Oh, well, that's just
So
be
5
high
1 over
natural
x
log
dx,
of
yeah.
X.
So it'd be 5 natural log of x. Excuse me. Oof. That took you down the wrong path with that one. Integral of natural log is much more complicated.
Okay. So I was thinking it'd be back and
Yeah,
forth.
no.
Yeah.
No.
Okay.
You try one now. Let's see what we got here. Hey. Now you can try one. Let's try integral of
Oh, I know this one. Yeah.
should be pretty quick. What's the answer?
Negative cosine x minus natural log of x.
Yep, it is.
Yeah, I was like sine x.
Last one, and then I'll let you work on your homework. Try. And I threw in some review problems on this too, just so you know. I did throw in some review stuff. I'll just give you one. Integral of Sure, why not? I'll do one more. There's something I want to make sure you know how to do. Otherwise, it's pretty easy.
So this is what I got so far. I split them up, but like. I don't know if that's right.
Close.
You done?
Yeah, I think. Yeah. Right. Yeah.
Oh.
Yeah, he just split it apart. He made the x to the 3 halves. He just square root of x. X to the 3 halves.
Oh.
Yeah, I didn't do that.
I didn't do that. So like.
Oh, oops, I went the wrong direction. Hang on, don't look at that. Excuse me.
Five x would be just five x squared, because you're increasing the parallel line divided by two. Divided by two. Because it's like divided by, yeah.
This is x to the 1/2 plus 1 is 3/2.
So, okay, so we don't have to like, for the x, we don't have to.
Nah.
I got one per row.
And since you're dividing by 3/2, it's the same as multiplying by the reciprocal, right?
Yes.
Yeah. Okay.
I forgot what the first was. I thought it was minus, because like minus 3 sine, but then I looked at it, it's like sine, negative cosine.
I know, it's like the easiest problem, isn't it? You're like, is this trick? Is this a trick? Guys, remember,
Isn't it
you
just
could rewrite this as,
5 times.
5EX.
so what's the answer?
5
5 to the
x.
x. Oh my god, that was like, my brain just like, it hurts and it
I know, it was so easy, it hurt. Okay,
If I
so,
see that during like an exam or something, I'm just gonna like, am I doing this right?
I
Like,
know, it seems like
beforehand,
it's too
gonna be-
easy. I'm throwing in e to the x in natural log because sometimes when you have, honestly, when you have to do integrals, usually in physics C on the exam, most of the points go in actually setting up the integral. The most points you'll miss for actually integrating incorrectly is 1 point out of 15 on a free response question, which is really not that big a deal. But every point counts, right? So I want to try to get you that way. A lot of times they have you integrating e to the x's and e to something because, you know, you're integrating an exponential because you're trying to find the area under the curve or something along those lines. The other places you find you do a lot of derivatives and integrals really because you're going back and forth between acceleration and position and velocity, etc. All right. So you've got the rest of your time, which is about 7 minutes until you get to go change to get started on that homework. You might be able to flash right through a lot of it. Yeah, absolutely.
Oh, we can't.
So-